Hi guys, it's Jason here from Technically Robust Recruitment, and today I'm going to be showing you how we can convert a decimal number into a binary number. Okay, so at first it can be a bit daunting because it's numbers, but I promise you it is really easy to get your head around once you've done a few practice tests yourself, a few practice questions, a few examples. You'll get your head around it pretty easy. So if you're struggling, just note down the basic steps and then do a few examples, and then you will get your head around it. It is not hard at all. Okay then. So moving on. So then what we need to do is there's 192 here, and we need to see which one of these numbers here fits into 192. Okay, so that is your first step. So we go, does 1 to 8 fit into 192? Yes, it does. Okay, so what we're going to do is just going to put a 1 here. Okay, so now what we need to do is we need to minus 1 to 8 from 192. Okay, so 192 minus 1 to 8 equals 64. Okay, so now we've got 64 remaining, we need to move on to the next number. Does 64 fit into 64? Yes, it does perfectly, so we will stick a 1 under here, and then obviously we have nothing remaining, so we do actually have the binary number already for this, so everything after this will just have a 0. Okay, so 0, 0, 0, 0, 0. Okay, so the answer is 1, 1, 0, 0, 0, 0, 0, 0. Okay, so now we've got the first number out of the way, we'll just move on to the second number straight away and get through these. Okay then, so just erase all these so I can start over. Okay then, so now we've got 168. Okay, so does 1 to 8 fit into 168? Yes, it does. So I'm just going to put a 1 under there. And then we do 168 minus 1 to 8, and that equals 40. So now we're left with 40 remaining. Does 64 fit into 40? No, it does not, so we're just going to put a 0 there. Does 32 fit into 40? Yes, it does, so we're going to put a 1 there. And we're going to do 40 minus 32, and that will equal 8. And then we need to figure out what number next fits into it. Okay, so again, does 16 fit into 8? Nope, no it does not. Does 8 fit into 8? Yes it does. And then we're at a balance of 0 then, so we have got our binary number in place. Okay, so the answer to that is 101 0 1 0 0 0. And let me just erase this so we can move on to our next octet. Okay then, so for 200, does 1 to 8 fit into 200? Yes it does. So we're going to put a 1 there, and that will leave us with 72. Okay, so does 64 fit into 72? Yes it does. Okay, so we're going to put a 1 there, 72 minus 64, and that will equal 8. Okay, so does 32 fit into 8? No it does not. Does 16 fit into 8? No it doesn't. Does 8 fit into 8? Of course it does. So we're going to put a 1 there, and then we've got our number, so everything from that point is just going to be a 0. So then the answer to that one is 11001000. Okay, and then moving on, I'll just erase that. Alright, so this is our last octet, so I'll just go a little bit slower on this one just to make sure Obviously we've gone through the other numbers now, so we can just make sure you understand this one. This is a little bit easier, it's a little bit of a lower number. So again, first, does 128 fit into 5? No, it doesn't, so we're going to put a 0 here. Does 64 fit into 5? No, it does not, so we're going to put a 0 here. Does 32 fit into 5? Nope. Does 16 fit into 5? Nope. Does 8 fit into 5? Nope. Does 4 fit into 5? Yes, it does. So we're going to put a 1 here, and then we're going to do 5 minus 4, and that will leave us with a sum of 1. And then we need to move on. So does 2 fit into 1? No, it doesn't. Does 1 fit into 1? Yes, it does. So that gives us the answer of 0, 0, 0, 0, 0, 1, 0, 1. Okay, so just to explain the steps to you guys again. So the first thing you need to do is figure out which one of these numbers below fits into the decimal number that you're trying to convert. Okay, so for 200 obviously it was 128, yes it did. And then the next step after that is you have to minus that number from the total. So that is that I forgot what that was. It was 72. Okay then. So then after that you've got obviously the remainder of 72, and you need to find out which number next fits into your remaining sum. So that in that instance was 64, and you just need to keep on going along until you come to a sum of 0. Once you come to a sum of 0, everything after that has a binary 0 against it. Okay. This will be useful for the subnetting that I may do a video on, in fact, myself. But basically, to do subnetting, which you will need to know if you do any networking exams, this is what you need to know. You just need to know the basics of binary, because in classful IP addresses you use 8 bits, 16 bits, or 24 bits. Whereas with classless IP addresses, which is what you use with subnetting, you can mix it up a bit, so you can have 10 bits used as the network address, or you can have 12 bits or 26 bits, and all it means is basically, so if all of these was ones, then that would be a class A address. But then if you wanted to use classless addressing, you'd make this a 1 as well, so then that would be a classless address. You'd be borrowing 1 bit from here, and then that's what we call subnetting. So you do have SIDR notation like this for that, so you just put a slash and a 9 there. So this is the purpose of knowing how you convert the IP addresses. Otherwise, you don't really need to worry about it. It's literally just for the subnetting. Okay. Thank you very much. We'll move on to the next video.